Welcome! In this lesson, we will be learning about how to write and recognize electron configurations of atoms that are in the excited state. So just as a quick review, excited state versus ground state electron configurations can help us figure out if we have an atom that's in the ground state or in the excited state. On the periodic table, all of the electron configurations that are given are in the ground state. So this is how the atoms normally exist in their most stable state. When the atom is energized by an outside source, various electrons will move to higher energy shells further from the nucleus, and that gives us an excited state. And the electron configurations, as our electrons move from one state to another, will change. So for beryllium, its ground state electron configuration is 2-2, and in the excited state, one of our electrons from n equals 2 pops over to n equals 3, right? So we're going from a lower energy level to a higher energy level, and the excited state configuration can show us that, exactly where our electrons are moving. So using our periodic table, we can determine if a given electron configuration is of an atom in its ground state or its excited state. So if we're given this electron configuration for potassium 2782, we want to know, is that in the ground state or the excited state? So first things first, we'll look at our periodic table and see what the ground state configuration for potassium is. And it turns out to be 2881. So once we have that, we can compare the ground state electron configuration with the one that's given. And they look a little bit different. They both have 2 electrons in the first shell, but in the second shell, the given atom only has 7, where the ground state atom has 8, and then in our n equals 4 shell, there's now 2 electrons instead of 1. So this means that one of our electrons has moved from a low energy shell to a high energy shell. So that means we're going to be in the excited state. Right, so we have to compare our ground state to our given information and see what happens. We can also draw Bohr models to help us visualize what's going on here. So we can draw the model of potassium in the ground state. So that's 2881. So I put my nucleus. Then I have my n equals 1, where I'm going to have 2 electrons. My n equals 2, where I'm going to have 8 electrons. N equals 3, where I have 8 electrons. And n equals 4, where I have 1 electron. In the excited state, my electron configuration is 2782. So I can do the same thing. My n equals 1 level has 2, n equals 2. Now has 7, n equals 3, still has 8. And now my n equals 4 has 2 electrons. So from going to the ground state into the excited state, we moved an electron from n equals 2 out to n equals 4. Right, and now our Bohr model can really show that. And we can do some more examples. of determining if an electron configuration is in the excited state or the ground state. So here we're given a list of different electron configurations. We want to know the element symbol and then determine if we're in the ground or excited state. So there's a lot of information in this electron configuration. So the first thing we want to do is count up the total number of electrons. So we have 9, 11 electrons here. And if these are atoms, then we automatically know that we're going to have 11 protons. And that's our atomic number, so we can look at our periodic table and see atomic number 11 is sodium, Na. And I can also look on the periodic table at my ground state electron configuration, which is 2, 8, 1. Then I can do a direct comparison, right? 2, 8, 1 is slightly different than 2, 7, 2, right? So it looks like in the given electron configuration, one of our electrons has moved from n equals 2 to n equals 3. So this electron configuration is going to be excited. We can do the same thing for our next one. First thing is to count up the number of total electrons. So we have 9 electrons, which is equal to 9 protons in a neutral atom. We can find atomic number 9, which is associated with fluorine. And fluorine has a ground state configuration of 2-7. So again, if we compare ground state versus our given state, they're different. And it looks like an electron has moved from the n equals 1 shell into the n equals 2 shell. So again, this one is going to be excited. For our next example, we'll add up our electrons. So 2 plus 7 is 9, plus 8 is 17, plus 2 more is 19 electrons. And that means we have 19 protons, which is potassium, with a ground state electron configuration of 2, 8, and 1. And again, right, we have slightly different electron configurations here, so some of our electrons have moved around. So again, we're in the excited state. For our last example, count up our electrons. We have 17 total electrons, which means we have 17 protons. And that correlates with an atom of chlorine, whose ground state is 2, 8, 7. And now, in this example, our ground state matches our given state. So that atom is in the ground state. So in this lesson, right, we should have learned that we can designate our electron configuration in both the ground state and the excited state, and we should be able to compare the two and see if we have an atom that's either in the ground state or the excited state using our periodic table and our information about protons and electrons that we already know. Okay, good job today. See you next time.